Okay, here are two additional limit problems. And in this first one, we're told to find the limit as x approaches 3 of 1/3 minus 1 over x minus 3. And you see that as x approaches 3, the numerator is 1/3 minus 1/3, so the numerator is 0, and the denominator is clearly 0. So we need to try to simplify this complex fraction. And so to do this, one way to simplify a complex fraction is to look at the little fractions within it and look at the denominators and find the common denominator, which would be 3x in this case, and multiply the top and the bottom by 3x. So this gets multiplied by 3x, and this gets multiplied by 3x. And so what do we get when we do that? Well, this is the limit as x approaches 3, and up top here, the 3x gets distributed to each of those two terms, and that first term is just 3x over 3, which is just x, and then we have the minus sign, and the second term is 3x over x, which is just 3, so it's x minus 3 over this denominator, which is x minus 3 times 3x. And then you can see the x minus 3 cancel. So we're left with the limit as x approaches 3 of 1 over 3x. And now we can just take this value of 3 and substitute it in for the variable right there, and we get our answer. It's just 1/9. So not too bad. You just need to be able to simplify a complex fraction using the standard techniques. Now if we wanted to graph this function, this original function, which would be this, f of x is 1 over 3 minus 1 over x minus 3. Well, graphing that now is pretty easy, because this expression here we've just simplified to this. So the graph of this function will look exactly like the graph of 1 over 3x. And we know basically what that's going to look like. It's going to look like something like this. It'll be a hyperbola. Except we can't have an x value of 3 because that would give us a 0 denominator. So wherever x is equal to 3, right here, there will be a little hole in the graph right there. So let me draw that. So that's basically what the graph will look like. It will look the same as a graph of 1 over 3x, except we can't have an x value of 3. The x value of 3 is not in the domain, so there's a hole in the graph. The function is undefined at x equals 3. Okay, here's one more. The limit as x approaches 0 of x plus 2 squared minus 4 over x. And clearly when x becomes 0, we have a 0 denominator. And when x becomes 0, this becomes 2 squared, which is 4 minus 4. So we have 0 over 0. So we can simplify this function simply by carrying out this operation here. And let's see what that gives us. We'll have the limit as x approaches 0. This will be x squared plus 4x plus 4. That's what we get from squaring that binomial there. Then we still have this minus 4. And then that's over x. And then clearly the plus 4 and the minus 4 cancel out. So we have the limit as x approaches 0 of x squared plus 4x. And I'm going to go ahead and factor that. I'm going to write it as x times x plus 4 over x, and then you can see those x's cancel. And so that leaves us with the limit as x approaches 0 of x plus 4. Pretty simple. As x approaches 0, this approaches a value of 4. So that's our answer. So if we want to graph this function, this mathematically simplifies to this. So it's just a graph of x plus 4, which is a line that goes through 4, 0 with a slope of 1. So it looks something like that, y equals x plus 4, except our original function here does not have a value of 0 in the domain because that would give us a 0 denominator. So we put a little hole in our graph right here at x equals 0. So let me just black that out and put in a little hole. That's what our graph looks like. It looks just like the line y equals x plus 4, except with the hole in it at that particular point.